Hello everyone, in this video we are trying to follow this book Cloud-Based Remote Sensing with Google Earth Engine Part A2 Aquatic and Hydrological Applications, Chapter A2.2 Benthic Habitats. This chapter describes on the ways to estimate the water depth from high-resolution planet data and the ways to map the benthic habitats. We see some real applied applications of the classification approach. We will see the random forest and other classification algorithms being applied. And this chapter is really wonderful. We see the real power of Earth Engine, and the codes in this chapter is bulkier, dense, compact, and there are so many things that we can reference in this chapter. And the attempt is just to go through the codes, and there certainly will not be the full coverage. This is just an attempt. So we begin with the very first section. In the first section we see the image being imported, and this is divided with some constant. We center it at the map section with the zoom level 12. We have the visualizing parameters, and we add this as the layer, and this is the image here. So this image has some blackish area in the most part of the image, and this is the area which is of interest, which is in the blue color. Then we move to the second section. In the second section, some training points, or the trainings polygons, are being created. So we can see here some lines for land, some lines for water as well, and some polygons for this DIV sand, and there is something for the sun glint. So the trainings polygons can be this line as well. This line will cover lots of points, so this will be very much effective for the trainings. So this is the section 2, and then we begin to this section here, and this is about creating the NDWI. Here we see the normalized difference water index being created, and then the training is being done for that image, and we just mask the non-water area. So here is the first codes here, the first function. So normalized difference water index is created, random forest classifies it, and then we mask the non-water area. And there here is this concept called the sun glint, and the sun glint is something that happens in the water surface. In the water surface there is something like the mirror-like reflection. So if there occurs this type of reflectance, or the mirror-like occurrence, so this will not help us to detect any reflectance from the ocean floor, and this needs to be corrected, and this is done by using the linear modeling. So what we see here is the selection of two different bands, band 4 and band 1, reduced it with the EE.reducer.linear feed, and this EE.reducer.linear feed uses the two different x and y variables, giving us the offset and scale. So basically this is the linear regression, and gives us the output. And we see this being repeated for different band combination, band 4 and band 1, band 4 and band 2, band 4 and band 3. And then we create the slope image by selecting the scale, and this dictionary is being converted into image here by selecting the scale, and by dot to image we are creating the image. And then we also have this band 4 being reduced to get the minimum value, and here the main things are happening. We're selecting the three different bands, we're subtracting it with the slope image. The slope image is itself being multiplied with this band faux, which is subtracted by the minimum value of itself. So things are happening here. So this is the way to remove the sun glint, and I cannot really go on further explaining the sun glint, as I am not much that aware of these things. But this is the way the book shows. We do the linear modeling for the two band combinations. We make the image from those scales, and then we do some here mathematical operations to do the sun glint removal. And there is this next concept called depth variant index. So this depth variant index is something done to minimize the bias of any spectral values. So that's happening in the water column due to the presence of any suspended material and absorption of light. This again is to correct the image from any types of the bias that is occurring in the spectral values. So here we see the kernel being created. We also see these values being changed into the positive values. So this dot Buir is the very nice way to do or classify the images. And here we see the function for the index. So here the bands are selected and some for loop is being created inside. But the most important thing here is this one here. So this is the formula or the expression for the calculation of the depth variant index. So the image 1 subtracts image 2, which is multiplied by the coefficients. And just before that, everything is being played with the arrays, and this is the most important thing whenever we do the programming, because we have to play with the arrays. So these arrays are the values in different dimensions. So this makes the codes for learners like us kind of challenging to understand, and these are the things to master anyway. So I cannot really go through the line by line is what is happening inside, but the main expression is here. The formula is here with image 1 subtracting the image 2, which is multiplied by the coefficients. And then we have this visualizing parameters, and you can see something like this here. So this is the masked image. This masked image contains only the watery areas. Then we have this sun glint removal. So you can see that the color is becoming a little darker after the removal of the sun glint. And then we have this depth variant index. So it is something like this, and it is probably working to remove any things that is happening due to the absorption of light or any biases. I cannot comment more on this. So this is the section where we do the sun glint removal and we do the depth variant index. And there is this next section, and in this section, from that image which has been corrected, we do the classification of different habitats. So we have the soft bottom for the sandy patches, rocky bottom for the rocky patches, and this pier for the some kind of seagrass patches. And these are the points or the training areas or the feature collection that is collected by going into the field. And then here we see this training points, or these points being classified into 70:30 ratio. Before that, we do this random column. So this is very much usable in our case as well. What we do is we in the feature collection we add this random column, and this after the addition of the random column we kind of group the data into the training and validation data. So anything less than this 0.7 will be considered as the training data, and greater than this 0.7 will be considered as the validation data. And in general, this is being done as the 70:30 ratio. So this is repeated for other two habitats as well, for the rocky bottom and the grass feature collection as well. And here we see the classification being done. The training dataset are merged into the big feature collection, and then some trainings are being done here, and here this classifier.lib SVM is being used. So this is the support vector machine, and then we see the classification being done. We do the error matrix, and then some the error matrix are being different kinds of accuracy are being printed. The important one here is this one, where they print the error matrix like this. So we can also print error matrix like this, and this here is a new thing for learners like us to do the error matrix in the console. So it appears like the like that in the spreadsheets. And what we see here is this classification. So if we see, so we have different training data here, validation data here, then the trainings and other types of the training and validation data sets. So the most important thing here is the classification. And so these three different habitats has been classified. And how the classification is working, or how the classification is has performed itself, we see these different types of the accuracy, and here are the user's accuracy and producer's accuracy, and here also the error matrix showing how many points or how many levels were correctly classified. So this is I think this is the second last section, and the last section here is about the bathymetry. And again, this bathymetry is about the observation of the depth of the water surface. And again, for the training, we have the feature collection. So this is again collected by going to the field location. And again, this is being grouped or grouped into the training and validation data. And then the vectors or the points are converted into the image for the classification, and we see this random forest being applied again, and then here the R square and RMSE is being printed. And the important thing here is this values of -50 to 0, and when this is applied as the layer, we see something like this. So in general, what is happening is we do the field data. Those field data are being converted into the training and validation data, and the these vector data set are converted into the images, and then the images are being classified using the random forest. But again, so many things are going on here, and this is it. I think I tried explaining little things as much as possible, but this is not the full guide in itself. So any comments are welcomed. Thank you for watching.